Nenomatica, where mathematics meets YouTube excellence. Example, we will solve the cube root equation exactly using a classic identity. First, read the problem in bold orange math. Step 1. Recognize the structure a plus b plus c equals 0. We will use the sum of cubes identity, then define our three pieces. A equals the cube root of x, b equals the cube root of 1 minus 2x, and c equals the cube root of x minus 1. Step 2. Apply the identity with our definitions. Cubing the three cube roots gives x, 1 minus 2x, and x minus 1. The right side becomes 3 times the product of the three cube roots. Step 3. Combine like terms on the left. X minus 2x plus x cancels to 0, and 1 minus 1 also cancels. The entire left side is 0. Step 4. A cube root is 0 exactly when its argument is 0. Therefore, the product x times 1 minus 2x times x minus 1 must be 0. Step 5. Solve each factor equal to 0. From x equals 0, we get x equals 0. From 1 minus 2x equals 0, we get x equals 1/2. From x minus 1 equals 0, we get x equals 1. Final step. Collect the solutions. The solution set is left brace 0, 1/2, and 1 right brace. Great work! Quick challenge. Verify each solution by direct substitution into the original equation. Summary. We used the sum of cubes identity with a plus b plus c equals 0, simplified to obtain a product inside a cube root, and solved each factor to get 3 real solutions. Practice this identity with other cube root sums. In this example, we will solve a cube root equation using the famous identity that when a plus b plus c equals 0, the sum of their cubes equals 3abc. Step 1. Apply the Euler sum identity. If a plus b plus c equals 0, then a cubed plus b cubed plus c cubed equals 3abc. Let a be the cube root of x, b be the cube root of x minus 2, and c be the cube root of x plus 5. Because a plus b plus c equals 0, we can cube and relate their sum to their product. Step 2. Express the sum of cubes and the product in terms of x. The cubes are x, x minus 2, and x plus 5. Their sum is 3x plus 3. The product a, b, c equals the cube root of x times x minus 2 times x plus 5. Step 3. Divide both sides by 3 to simplify. Step 4. Cube both sides to remove the cube root. Step 5. Expand both sides. On the left, x plus 1 cubed equals x cubed plus 3x squared plus 3x plus 1. On the right, x times x squared plus 3x minus 10 equals x cubed plus 3x squared minus 10x. Step 6. Subtract x cubed and 3x squared from both sides. We get 3x plus 1 equals negative 10x. Step 7. Add 10x to both sides to combine like terms, giving 13x equals negative 1. Then divide by 13 to find x equals negative 1 over 13. Example. We will solve the equation, the cube root of x plus 1 plus the cube root of x plus 2 plus the cube root of x plus 3 equals 0. We'll follow a clean, step-by-step plan and highlight each rule we use. Before we start, note the domain. Cube roots are defined for all real numbers, so x can be any real. Step 1. Recognize that we have a sum of 3 terms equal to 0. Let it be the cube root of x plus 1. B be the cube root of x plus 2, and c be the cube root of x plus 3. When a plus b plus c equals 0, the identity says a cubed plus b cubed plus c cubed equals 3abc. Apply this identity directly. Step 2. Simplify the left side. X plus 1 plus x plus 2 plus x plus 3 equals 3x plus 6. Step 3. Divide both sides by 3 to isolate a single cube root. Step 4. Cube both sides to remove the cube root. Step 5. Cube both sides to remove the cube root. Step 5. Bring everything to one side, so it equals 0. Step 6. Factor out the common factor x plus 2. Now expand the bracket. X plus 2 squared is x squared plus 4x plus 4. And x plus 1, x plus 3, is x squared plus 4x plus 3. Their difference is 1. So the only factor that can be 0 is x plus 2. That gives x equals negative 2. Let's check it in the original equation to be sure. x squared plus 4x plus 3. Their difference is 1. So the only factor that can be 0 is x plus 2. That gives x equals negative 2. Let's check it in the original equation to be sure. Is x plus 2. That gives x equals negative 2. Let's check it in the original equation to be sure. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. Nenomatica, where mathematics meets YouTube excellence.